Good morning everybody, my name is Camilla Vertua, I am DC7 and today I am going to present my research which is entitled Toward Net Zero Carbon Facades, Biocircular Strategies for Curtain Walls Retrofitting. This research is more specifically the product of the collaboration between Politecnico di Milano and Leuven as first and second affiliation respectively, and Schüco as industrial partner, and it was developed under the guidance of my supervisors, Professor Carol Monticelli and Jan Wurm from Politecnico di Milano and Leuven, and my co-supervisors, Professor Alessandra Zanelli and Alessandro Dama, both from Politecnico di Milano. This research starts from crucial questions for us as architects, which is how do you increase energy efficiency of office buildings with very low embodied carbon? Indeed, office buildings, although they are just 1/3 of the total building stock in Europe, represent around 50% of its total energy use, and for that reason, their retrofitting is today considered primary. In this regard, post-1970s office buildings often feature curtain wall facade, which are facade systems completely independent from the structure of the building and mostly presenting high percentages of glazed surfaces in combination with precious materials such as aluminum and steel. This type of facade have normally an operative life of 30 years, which means that today their retrofitting is expected, although if not responsibly managed, it might result in quantities of solid waste and related lost value. At the same time, the high rate of transparency is today questioned by rising temperatures due to climate change, which is overloading the HVAC systems of office buildings, and by the progressive change in being used following service digitalization post-COVID-19 pandemics. So, we are trying to propose a retrofitting strategy for this type of facades combining circular construction and biocircular principles in order to reply to the needs we have just listed by using bioresidues for the production of thermal insulation, and more specifically mycelium-based composite thermal insulation, in combination with remanufactured glass and metal reuse in order to tackle both embodied carbon and operative carbon of office buildings that were built between the 80s and the 2000s, and for this reason are soon expected to be retrofitted. More specifically, in this framework, we are envisioning two typologies of retrofitting strategy. On one side, we are going to compute the embodied carbon savings we might get from the use of secondary curtain wall components such as remanufactured glass and metal reuse in combination with mycelium-based composite thermal insulation in order to see what we can get compared to a curtain wall made of virgin materials. On the other side, we are trying to define a new technology based on the indoor overcladding of an existing facade which remains where it is with mycelium-based composite insulation in order to reply to questions of overheating and to accommodate eventual change in building use. So, the first type of study we are doing is more specifically addressed to facade suppliers and building components producers, and it informs on the eventual embodied carbon savings we might get from the use of an alternative curtain wall module. In order to quantify the environmental savings we might get, we used a case study and we compared two curtain wall modules as completely identical except for the fact that one is made of virgin materials, while the second one featured remanufactured glass, metal reused, and mycelium-based composite thermal insulation. So, we compared the two modules overall their life cycles, envisioning more specifically three possible end-of-life scenarios, where either all the composites they're made of are landfilled, reused, or recycled. And from what we can observe, we saw that basically reusing or remanufacturing curtain wall components is definitely more energy and cost efficient than downcycling them. And also we saw that the more cycles the better. What does it mean this? It means that even when we landfill all the components the alternative curtain wall module is made of, we become still carbon positive. If we reuse or recycle all the components of the remanufactured curtain wall module, we become carbon negative. That means that reusing the materials for more cycles is more environmental friendly, basically. For the second typology of application, we decided to technologically develop a completely new retrofitting strategy. And this was a type of application that we thought for as a solution for architects, office building owners, and end users. Indeed, more specifically, we wanted this solution to be adaptable to multiple curtain wall configurations, to be low-intrusive, and to be fast in order to be mounted in just a few steps, as it was a DIY technology. And to do so, we developed a new wall package made more specifically of 3 centimeters of mycelium-based composites in combination with a reflective foil, which avoids possible overheating problems between the existing curtain wall, which remains where it is, and the additional thermal insulation, and finished by a layer of vapor barrier in combination with a finishing, which can be adaptable to the multiple needs, for instance, or multiple aesthetics. According to our analysis, where we applied this type of configuration of 50% of a completely glazed facade on different altitudes in Europe, we saw that basically we could get energy savings ranging from 30 to 50%, depending on the different geographies of application, which might result in consistent economic savings. At the same time, we saw this solution as a fast and non-intrusive and flexible and low-cost strategy, which might be interesting for different users, as we said before. However, there might be some possible concerns regarding our envisioned strategy. First of all, regarding mycelium. For instance, some people may ask themselves if mycelium is going to kill them with their spores. Or some other people may ask why overcladding their facade and why opacizing part of it. While some others may have some questions related to durability of this solution and on the marketability of the solution we proposed. So, regarding the first doubt, no, mycelium is not going to kill you, because when we produce this mycelium-based composite thermal insulation, mycelium is already dead. Indeed, the composite is dried in order to stop the growth of mycelium before the body is fruiting, the body of the fungi is fruiting, which is what causes the spore release. Why overcladding your facade? Well, in order to reduce possible overheating problems or to accommodate eventual change in building use, which might need more privacy. Is this a durable solution? Well, this is a new technology, which means that there are also new challenges and new tests to be done. Mycelium thermal insulation can be durable if not in contact with water and can last for years, but at the moment there are no projects that kept mycelium for more than 20 years, and we are not able to determine in a very clear way if this composite has the same duration as, for instance, stone wool or other typologies of more conventional thermal insulation. And is the new wall package ready to be placed in the market? Well, we're not still at that stage of industrialization, but we made a prototype, and we are monitoring this prototype when applied to a facade. Let's see, to be defined. It's something that is possible. Today, no, we are not yet there. At the moment, this is what I've done till now, and I thank you for your time and for your attention.